We now know the common mode and differential behavior of the differential pair with the current mirror load. I will assume that the gate of this is connected to some current mirror arrangement such that the tail current is I naught. A small signal model for differential signals is a transconductance of GM1 and an output conductance of GDS1 plus GDS3. Each of these is calculated at a quiescent current of I naught by 2. Okay. And as far as the common mode signal is concerned, okay, the common mode gain, what was this? We had it here, right? Approximately minus 1 by 2 GM3 R naught, minus 1 by 2 GM3 R naught, or basically minus GDS 0 by 2 GM3, where GDS 0 corresponds to the output conductance of M0. Okay. So, with this we should be able to analyze anything. Okay. In general, the operating point of these two, remember this will be used in feedback. So, this VICM is whatever the quiescent point is set after feedback is applied and so on. And over this, any signal that we have V1 and V2 can be decomposed as a differentially applied signal and a signal applied as common mode. For differentially applied signals, you use this model. For common mode signals, you use that model. That's all. Okay. So, that is more convenient than trying to analyze them in terms of individual voltages V1 and V2. Okay. We have a large differential gain and a small common mode gain, and that is exactly the behavior expected from an op amp. If the op amp was ideal, the differential gain would be very large or infinite and the common mode gain would be 0, it would not respond to common mode at all. Okay. In reality, we neither have infinity nor 0, but we have large and small values. Okay. Now, we can apply signals to this and then we can use this itself as an op amp. Okay. It is not a great op amp because it behaves like, first of all, the gain is sort of limited to about 100 or so, and the output resistance is not very low. Okay. So, what happens is if you load this with a resistor, the gain reduces further, but still in some situations, if you do not have a resistive load, you can use this. Okay. As an example, let us try and make a voltage follower with an op amp, which is a voltage controlled voltage source of gain 1 or a unity gain non inverting amplifier. Okay. So, if I have Vi here, this incremental output should also be the same as the incremental input, that should be equal to Vi. Okay. So, what should we do in our op amp to make this connection? Yeah, all we have to do is connect it up like that. Okay. And here we apply the input signal Vi. Okay. Now, what is the quiescent output voltage? So, let us say this is biased at some VICM. What is the quiescent output voltage? Really? Why? VICM. Why? Same current? M2. Why? Yeah, it's an op amp and negative feedback, but let's say we didn't know about the op amp or anything. I just gave you this circuit and asked you what the output voltage was. How would you reason it out? What's that? Yeah, exactly. So, it is true, the same currents will have to flow. Again, you can, I mean, it is true, the op amp is providing negative feedback and the same negative feedback action we can see here, right. So, just imagine that this was slightly more than I naught by 2 and this current was slightly less than I naught by 2. The total current is fixed, right. So, what will happen? M3 and M4 is a current mirror. So, what will be this current? I naught by 2 plus delta, because this goes through this current mirror, it gets mirrored. So, now you can see that the pull down current is smaller than the pull up current. What happens? Again, you can imagine a parasitic capacitance like we have done in all the negative feedback problems. So, initially whatever this voltage was, now it will keep rising until when these two currents become equal. So, that means that I naught by 2 and I naught by 2 are flowing here, that means that this voltage has to be equal to VICM. Okay. Is this clear? And that is exactly what this is also saying. So, you just imagine that initially the output is smaller than the input, then the op amp will drive the output until it becomes equal to the input. Okay. So, the feedback works for the quiescent condition as well as for incremental signals. So, the quiescent output voltage will be VICM. Okay. Now, in this particular analysis, I have sort of ignored GDS and so on. If you throw everything together, you can do the small signal analysis, you will find that it may be slightly different from that. Then I apply some signal Vi. What will be the incremental output? What will same, and you can follow exactly the same reasoning, right? You just imagine that this voltage is different from Vi. Okay, then the currents in M1 and M2 will be different from each other. Okay, what will happen? The current in M1 will get mirrored in M3, get pushed through M4. The difference current will keep on changing the output voltage until this current becomes equal to that current. Eventually, the currents in M1 and M2 have to be the same. Okay, so that is what happens in an op amp, right? This can be described in many ways, but the virtual short finally happens because of negative feedback, these two currents will be forced to be the same. So, that means that this gate voltage and that gate voltage will have to be the same. Okay. So, that is how the virtual short occurs in an op amp. Is this fine? Now, in presence of GDS and so on, there will be some small errors that you can analyze, right. So, you should be able to figure out the same things either from large or small signal reasonings, but this is a unity gain buffer using an op amp, and this can be used. This is sometimes used. The point is, if you do have a resistive load, and just for simplicity, in order not to disturb the biasing, I will AC couple that. Okay. So, this is just so that I do not change the operating point here. What happens in this case? Yeah. So, first let us look at the small signal model of this alone without RL. What was it? The small signal model of the op amp. Okay. How do we make the unity gain buffer? I do this and the incremental input is applied there. Okay. What will be the output voltage? Now, including everything in the model, what will be the output voltage? Yeah, not approximately, but exactly what is it? Please calculate and tell me what is the value of VO? Approximately true, yeah, it will be, but what is it exactly? If the gain of the op amp here was A naught, what would be the output? A naught by 1 plus A naught, or 1 by 1 plus 1 by A naught times Vi, and here also you get the same thing. I mean, you said GM by GM plus GDS1 plus GDS3 times Vi, which of course is the same as 1 by 1 plus, and I put the GM here. And what is this? This is the reciprocal of the gain. Okay. A naught is GM by GDS1 plus GDS3, right. So, you get exactly that. You get slightly smaller increment than what you apply at the input. So, those things can be got by small signal analysis. Okay. And if you do design the op amp to have a large gain, as you most likely will, then the output will be approximately here. Okay. This is fine. Now, so this is the small signal behavior. What else do we need to discuss?